All right, so let's get into why functional programming, and specifically, let's start getting into some of the topics that we're going to be talking about. So I'm going to switch over to Sketchbook over here so that I can show you with a little diagram. And again, this is why I think it's so important that we cover these bases first, because once we get into it, you will see that once you understand the intent behind why functional programming exists, and the reasons why everybody, or there's a lot of enthusiasm around this community. But I think before we get into that, it's important to understand what it tries to solve versus object-oriented programming. So let's think about what a program is, and let's take a step back for a second. Okay, so if we think of a program, okay, usually what we have is this. Usually we have some data somewhere. Okay, then we also have some way to display the data. So we'll call this the UI. And then what we have is usually somewhere that we can make some API that we're calling or our server. Okay, and this was really the model for a long time. So this is the MVC kind of framework, which is Model View Controller. And if you guys have ever worked with Ruby on Rails or anything like that, this is kind of the style that those frameworks that they adopt. Now, when React came along, and if you have done any React programming, then a lot of functional reactive programming started becoming more into the forefront. But again, it kind of goes to show that this is what big companies like Facebook, companies that have code bases that are large and need to be maintained, this is the approach that they opt into. Okay, so there's kind of a clue of how important this is, and that's when it really becomes important. So when you're thinking about how to architect your programs, and not just architect, but how does the program actually work, and that's kind of what let's go over that now, so that you can kind of get a deeper understanding and actually know what's happening behind the scenes of your program. So again, the MVC model is it's a good model, but as you start scaling, you will see that that it kind of hits certain limits. Part of the limits, it's maintainability. Okay, so maintainability is such a huge thing, especially if you're trying to grow a team, especially if you're trying to become a developer and incorporate yourself into a team. Have maintainable code is one of the things that will stop any team the most. Just debugging. Debugging, if you don't set up your programs correctly, it just becomes a nightmare, as you start scaling. Also, complexity. And this kind of deals with maintainability, but complexity is a little different. And this is, I'll try to differentiate interoperate. So interoperate, I don't even know if I spelled that correctly, but you get the point. Interoperate is, do we have different pieces that all work together? So maybe you've heard of the concept of these legacy applications that are monolithic. Okay, and there's there's different way of creating an application that the code base is not necessarily monolithic, but instead is componentizable. Okay, components. So usually when we're doing functional programming, we will focus our attention a lot more on creating reusable pieces. It's kind of like Legos, okay? So think of it like Legos, okay? And whereas in object-oriented programming, we deal with classes and inheritance. Okay, I don't know why I spelled that way. So let me just, okay. And an inheritance. In functional programming, we are going to be dealing with functions as first-class citizens. Okay, and we'll go over a little bit more on what that actually means. Functions as first-class citizens. Okay, all right. So again, part of the big benefit of all this is that our application. Let's say we create. Let's just go over a simple. Let's just go over a simple, usually a pattern that you'll see a lot in the wild with the MVC, okay? Let's say you have a model, okay, and this model we're going to call it car. And let's say you have another model called truck, okay? And maybe you're trying to, maybe you're Uber, okay? And you're doing food delivery, okay? And food delivery. And then for that, you use trucks. And then let's say you also have a taxi company, Okay, and then that's the taxi part of the company. So you have these two models, and they both, okay, and we'll specialize this from from car to taxis. Okay, so both taxis and trucks, they're both vehicles. Okay, so maybe they inherit from a class called vehicles, and the vehicle class has maybe drive forward, back, okay, and that's it. You know, maybe forward, back, and brakes. Let's put some brakes on the car. Okay, so that's your model. Okay, and then the car or the taxi model also has a few things that all vehicles don't have. So it has like a meter, right, for you to know what to charge, distance traveled, okay, and then the truck model, it has also distance, but it has other stuff like let's say shipment, cargo, destination and origination, um, and again this is just a okay, and destination, and maybe a driver. Whereas over here we might have a passenger. Okay, so although both of these models do inherit from vehicle, because they, you know, since they're both vehicles, we can kind of say and we can reason that they're both, you know, are going to go forward, back, and they'll both have brakes. So that's what they have in common. But then we start seeing that you know, these things are the stuff that they don't have in common, right? So when we're trying to create an API against this this interface, this is where we start diverging, right? So this is where we start okay, and this is where our models they start to grow. You can see how this you know, kind of pretty soon it gets unmaintainable if there's not a lot of thought behind this type of code base. Now, in functional programming, the big difference, okay, and the whole thing that we usually talk about is there's this thing called data, okay, and what the functional programmers what they tell you is, you know, think of your app not as the UI, not as the model or the controller. Think of it as just the data, okay, and everything else. Okay, let me okay, and yeah, everything else is just there to serve this data. So usually we have transport layer. Okay, so we're gonna go over the layers of what the application actually does, right? So there's a transport layer. There's usually a mutation layer. Okay, mutation layer, and we'll explain this in a little bit more detail. Transportation, mutation, okay, and then display, okay. So the data is what becomes important, okay, and the transportation usually is maybe is a server, okay, maybe it's a database, okay, maybe it's just an object, okay. So, but the transportation pretty much is where are we moving the data from and to, okay. So that's the first part of how the data moves. Then there's the mutation part of the data. So the mutation is, you know, we have the data in a certain way. So maybe we saved it as in a certain shape. Let's just call this shape, right? And the shape of the data is exactly what we were talking about just a second ago, right? So it has, you know, maybe a car model has miles driven, drivers, okay, and maybe this is an array, okay. Miles driven might be like just a number, okay. Maybe this is just a number. This is an array, okay. So a collection, and then we have maybe color or something, whatever, you know. You get the point. And this is a string. Let's just say. So then we have the data in a certain shape, right? But then as we maybe want to display it, okay. So as we move from the transportation to the display, we have this intermediate step, which is called the mutation, which is what do we want that data to look like, right? Because our UIs or the client, let's just call this the client and the server, right? So the server, and then this is the client, okay? So the client has certain needs, okay? So because the client has certain needs, the client wants to display data in a certain fashion. So if you have a user logged in, it might be a completely different display than a logged out user, right? Or if you have a driver of a taxi company, of one of the taxis, their display might be different than the truck driver's display, right? Okay. So what we can see is in functional programming, we kind of think of everything in this model. Okay, there's the data, and then there is the transportation of that data. Then there is the mutation of that data, which is getting it from a way that was in, right? So whether it's in miles, drivers, and color, maybe we want to, maybe part of the UI doesn't just want the miles, but we want to multiply miles times gas price, right? And then that will tell us maybe how much the drivers, like, maybe we're doing a cost analysis, right? Okay. And we want to display that for admins or something, or managers. Or maybe we want to say also from miles for taxis, we want to say times customers, right? So miles times customers maybe gives us the average customer value, right? So although we're both getting this miles attribute from the data, we are going to do different things with it, right? Depending on the UI and depending on the needs of the UI. So this is where it's so important to separate this layer from data, from the transportation, okay, to the mutation, to the finally the display, okay, and that's pretty much it. Okay, so pretty much the way we want to think about data from now on, or applications, is not inheritance. At least if you're adopting this model, inheritance, okay, where things inherit from classes, okay, and then we have the vehicle class, and then two classes under that which inherit the the movement behavior of a vehicle, and then the specific behavior, let's say, of each model. We want to think more in terms of functions that are just trying to do a few things, right? So they're either going to be getting data, getting or reading data, reading or writing the data, okay, getting the data, moving the data, okay, changing the data, and we'll talk about changes and how in functional programming we actually want to be very mindful of how we actually do make these changes, changing the data, okay, and then showing the data, okay. So now we have not this inheritance model that we have with object-oriented programming, but we have this different style of thinking about how we're going to create our applications, okay. And the style is usually we're just working with data, so it's data all across, okay. And if you really think about applications, you will see that this actually does make a lot of sense, and most of the applications do follow this pattern. So you have some data, you want to move it from somewhere to somewhere, you want to change the way that data looks depending on what the needs of the client is, and then you actually want to show it to the client, right? And if you can separate, and if you can break up your application into these different forms, then you'll have a better understanding of where we're going with the class, okay? So now that we have talked about that, okay, so now that we've kind of set the stage for a little bit of the difference between object-oriented programming and functional programming, let's actually get into some of the stuff that that we'll be covering in the class. And one of the first things we're going to be starting with is functions, because like I said, functions are first-class citizens when it comes to functional programming, and everything is a function. Okay, so let's get into that.